Hello everyone, I am Udaya, working as Assistant Professor in the Department of Agricultural Engineering, Sri Shanmuga College of Engineering and Technology. In this lecture video, we are going to discuss about the topic remote sensing. So, welcome to the session on remote sensing. As you can see in this image, you'll be able to see the picture of Earth, and there are so many satellites revolving around the Earth. So, this is the basic concept of remote sensing. Satellite being located in a remote place, it is sensing and getting information about Earth. Okay, satellite captures photographs of the Earth and it measures temperature, humidity, like various parameters. Okay, so there are so many sensors we attach to the satellite. Those satellites revolve around the Earth and it collects various information. So this process is called remote sensing. From a remote place, we will be able to collect information about a particular object. For example, we would have all seen television remote. So television remote saves us from going near to the TV and increasing the volume or changing the channel. But being sitting in a sofa or chair, we are able to access or change the features in our television sitting in a remote place, and we are getting information from the we are getting information or changing the features of a television. Okay, so similarly satellite being located in a distant place, but it collects features on, above or below the earth surface. So coming to the definition of remote sensing is also an art as well as science. It is used to obtain information about the object without being in physical contact with it. Okay, so we don't need to go to that particular place in person. We can sit in a remote place, but we can access what is happening there. So simple example is that we are all seen cameras fitted on the room. So for example, in a college or school classrooms, a camera is placed. The principal or the HOD or headmaster of the institution, they will be sitting in their cabin and they are accessing what is going on in the class. Okay, so this is what we call as remote sensing. In our human body, our eyes, ears are also remote sensors. So we would have all able to smell what our mother cooking in kitchen, and we will be able to hear the sound of any vehicle which is traveling, which is passing in the streets or roads. So by sensing the sound itself, we will be able to identify this is a car, this is a bus, like that. So our eyes and ears are remote sensors. So remotely sensed product. So aerial photograph, satellite image, these are all the examples of and remotely sensed product. So source of energy for remote sensing is sun. Okay, so sun, we can also call it as solar radiation, or we technically we can also name the sunlight as electromagnetic radiation. We will discuss about electromagnetic radiation in detail in the forthcoming videos. So now coming to the types of remote sensing, there are two types of remote sensing. One is passive remote sensing, the other one is active remote sensing. So passive remote sensing, as you can see in the image depicted, so the source of radiation for passive remote sensing is sunlight. Yes, in the presence of sunlight only we will be able to collect information. Okay, so the source of radiation or the energy required for doing remote sensing is sun. So it passive sensors are designed in such a way that it detect natural radiation that is emitted or reflected by the object. So the best example for passive remote sensing is film photography. The main drawback of passive remote sensing is that in the absence of sunlight, we will not be able to collect information or procure the data. So next, coming to the active remote sensing, here as you can see in this image, the sensor itself emit the radiation, scan the object, and it collects back the reflected radiation from the target. Okay, so here no external energy source is required. The sensor itself produces its own energy. It emits that energy source and it collects the reflected energy. Okay, so here the remote sensing happens both daytime, nighttime, anytime, any climatic conditions. So remote sensing will happen. The best example for active remote sensing is radar. So here the detailed differentiation between active and passive remote sensing systems. So energy source for active remote sensing, the active sensor itself generates and uses its own energy. Passive depends on solar radiation. And the region of spectrum in which they operate. Mainly active remote sensors operate in the microwave region because it have a longer wavelength. It's a wavelength longer than 1 mm, and the region of spectrum for passive remote sensing, it is visible region and infrared region and some portion of ultraviolet also. Okay, so and visible region ranging from 0.4 to 0.7 and infrared ranging from 0.7 to 10 micrometer. So the best example for active synthetic aperture radar and passive remote sensing, camera without flashlight. So now coming to the most important topic of remote sensing, what are all the components used in remote sensing? The main and the most important component is the energy source or illumination. So for passive remote sensing, we depend on sunlight or solar radiation or electromagnetic radiation. So it is the natural source of energy. We use it for remote sensing. Next, the most important component is the radiation from the atmosphere. It travels from sun to the target, that is our earth surface. Before doing remote sensing, the radiation travels twice, one from the sun to the target, then the reflected energy from the target to reach the sensor. Okay, next the component is interaction with the target. The incoming solar radiation interacts with the earth surface. Earth surface having n number of features like roads, railway network, and trees, forest, water bodies, buildings. There are so many features on the earth surface. The radiation, it hits each target, and based on the characteristics of the target, it is reflected in its own pattern. Next, recording of energy by the sensor. So the reflected radiation is collected by the satellite sensor. So the sensor should record the radiation as it is, and then the transmission, reception and processing. The sensor collects the data in its own form, but it should be analyzed by the common man in the final format like map or the processed image. So the transmission, reception, processing, this process can be done by the mid users. Okay, so the engineers or analysts, they do processing, and the end users will do interpretation and analysis. Then final application will be to people. Okay, so these are the basic components remote sensing. So coming to the detailed description. For doing remote sensing, we require a platform. Platform is nothing but a vehicle which carries a sensor, that is satellite, aircraft or balloon. So these are the platforms which carry our sensors. Sensors are nothing but a device that receives the electromagnetic radiation and converts it into signal that can be recorded and displayed either as numerical data or image. One platform can carry more than one sensor. For example, a GSLV satellite can carry more than one sensor like Landsat TM, ETM. So Landsat is a satellite series. TM is thematic mapper, it's a sensor. Enhanced thematic mapper is the advanced version of thematic mapper. Okay, so it varies in the number of bands. Okay, so we will discuss about bands, satellite sensors in detail. Okay, so next component is the energy source. It's sunlight. It's electromagnetic energy. Next, the radiation and the atmosphere. As I already mentioned, the energy travels from its source to target, and it will come in contact with the atmosphere it passes through. then it's reflected back and collected by the sensor. Okay, so these are all the components of remote sensing. This is the pictorial representation on how remote sensing is working. So sun is producing the incident radiation. So as you can see, the multiple objects like forest, water, grass, bare soil, paved road, built up area on the Earth's surface. The incoming radiation hits these objects, and the reflected radiation from these objects are collected by the satellite sensor. So this this description, it is the component. It resembles the component of remote sensing. The next important thing is that principles of remote sensing. So the principle of remote sensing mainly based on the incoming radiation reaching the Earth surface, and different materials such as water, soil, vegetation, buildings, road reflect visible and infrared light in different ways. So they have different colors, brightness when seen under the sun. So the detection and discrimination of objects or surface features means detecting and recording of radiant energy reflected or emitted by objects or surface material. So this depends on property of material, surface roughness, angle of incidence, intensity, and wavelength of radiant energy. So these are the principles of remote sensing. So now we will have a glimpse on what I have explained in this topic. So there are two types of remote sensing majorly: passive remote sensing, active remote sensing. In this image, you can find passive remote sensing. So here sunlight, the keyword is sunlight. Okay, with the help of sunlight, remote sensing is done. So next picture, it shows how active remote sensing working. The sensor itself producing its own light source, and it is doing remote sensing. The reflected radiation is collected by the sensor. Okay, so no external source like sun is required. During any weather condition, any time, remote sensing can happen. Then coming to the components and principles of remote sensing, we will be able to see the solar radiation, incoming radiation, incident radiation, and reflected radiation collected by the sensor from satellite sensor to ground station, where the processing can happen. Okay, so this is about the introduction to